Hi, and welcome to this episode of Shop Miscellany, where I go over some recent acquisitions in the shop, do minor jobs, that sort of thing. This time around, I picked up a bunch of different items that I thought I'd show you. Some are interesting, some are kind of mundane. This one's kind of mundane. This is, I don't know, it feels like about a pound, but it's 250 grams, so it's half a pound. Shows what I know. 250 grams or 1,250 carats of 1 to 3 micron diamonds, to equivalent of 10,000 grit. And it's just rough diamonds in there that you can use as lapping compounds. So these are just dry diamonds, so they're easy to store. They don't leak or dry up. You can mix with some light oil, WD-40, or even water if you want to do some lapping. Your choice, which is useful rather than buying it already in some carrier. Although sometimes the carrier solutions they sell help keep the diamonds in solution. They have something in the solution that helps keep the diamonds floating about rather than settling out. This one I won't have, that kind of luck with, but it's fairly fine, so I think you shake it up and it'll work pretty well. Found it on eBay. You can go check it out. There are other ones out there. This was not very expensive. I think this was like 20 bucks. Next up, you've got the common Machinist Jack. This is a really cheesy one, really inexpensive. I think it's like 10 bucks or something. Not that this isn't the one I wanted to show, just want to show sort of the idea of what I'm showing. Instead, I wanted to show these couple of Machinist Jacks I found on eBay. I got this one a while ago. This one's an at ease, and it's just machine surfaces. It's not ground, but very smooth motion, dual incline plane that keeps the sides parallel while giving you a little bit of range of motion. I think when it's all the way down, it's pretty close to the bottom of a Kurt Vise, the base of a Kurt Vise, so pretty handy, that design. And then Edge Technology just came out with one. I saw this on another channel, and I thought I'd pick one up. Love to check it out. The Edge Technologies jack is kind of interesting. It's made in multiple pieces, so it's got the riser part, which is Acme threads as opposed to standard threads. Like this uses a standard bolt. This one uses cheesy soft steel material with standard threads. So none of these can support a lot of weight. This one, fortunately, you're pulling perpendicularly, so only some of the force is pulling against the bolt here. Actually, you need more force because some of force goes this way and some of the force goes vertically the way you want it. So some of the force on the bolt is actually wasted. So if you're going to apply a lot of force, this is not the jack for you. This one, however, has Acme threads, which are very strong and provide a lot of mechanical advantage. So this would be the way to go if you're going to actually use it to apply torque. They've got holes through the center to let you put a rod in here to get a little force when you're tightening this guy up. There's a hole down the center, which is kind of interesting because it looks like, at first I thought this was bolted on, but no, they just drilled a recess in it. Interesting. This is held captive by an offset Allen head screw in the bottom of it. That's interesting. Neat choice. 4 screws hold the bottom plate on. The bottom plate is set so you can bolt this down to your milling machine table. It comes with a T-slot bolt. This is just under 5/8. It's 0.6 inches instead of 0.625, and a 1/2 inch 13 bolt and a cheesy washer. That's not worth using. I'll toss that out of the way. But the rest of it's pretty nice. Has 3 set screws on the side. I'm not sure why 3 yet. I'm sure 1 locks this off, but I'm not sure what the other 2 do. I think one way to find out would be to remove the piece completely out of the center. Feels like they Loctited that a bit. They did. They used red Loctite on it. Okay, so now it can come all the way out. The center set screw, pushes on a piece of brass against the threads, so that's how you lock the column height. I guess these other 2 just hold this machine piece on, just for appearances. That's all it does. That's interesting and kind of bizarre. The fit and finish is really nice. So these 2 screws here just hold this pretty faceplate on. This one pushes against a brass piece that you can start to see right there that pushes on the threads that helps you lock the height when you're done. So that's a nice feature. All in all, of all of these, I think this is one of the nicest. This provides decent platform. The one reason I like this one and why I got this one first, is that this provides a very large support platform. So if you're just trying to snug it up under a part that you're going to do some machining on, that's pretty handy. And if you can't get the height, you can always stack a 1, 2, 3 block or something underneath it to get the height you need, and it still has adjustability. However, this method of tightening a bolt perpendicular to the motion. When there's a 30-degree slope here, means that only some of the force applied with this bolt goes vertically and the rest of the force goes horizontally, which means that you're putting a lot more strain on the bolt for a lot less motion. So this is not the kind of setup you'll use if you have something heavy and you're trying to actually jack it up. If you want to compensate. This one, you've got a lot of leverage on. It's a good design. I think Edge Technologies did a really nice job with their fit and finish, and I like the fact that you can bolt it to the milling table if you need to use it. I know where I saw this now. A-Bomb got one of these. They probably sent it to him. He's got a great channel. Check it out if you haven't seen it. Next up, we have a turning tool, this Kennametal right here. There's the part STFCL2525M16, which makes this guy an inch shank, so you might need to look for smaller, like 2020, which would be roughly 3/4 if you have a smaller lathe than I do. And the beauty of this guy is you can turn it into a shear cutting tool very easily. Because of the way it holds this, you can machine this guy. You can take this end of it and profile this whole thing, hold it at an angle, and cut this at an angle so that it sits like this. And you can turn this into a shear cutting tool that holds triangular inserts. Very nicely made. Or you can just use it as a standard triangular left-handed cutting tool. You can see the L at the end of this. That is left-handed cutting tool, which means it cuts coming from the left, going right. It works either way. The other one of these I had was in poor shape, and this one came up as a really good deal, and it's actually Kennametal, so it's probably really well made because the other one was just a no-name Chinese brand. So I picked this one up. I got it for like $40 or $30, which I thought was a really good deal. Next up, you've probably seen these for my powered tapping arm, and they're GT12 torque-controlled tap holders. And you just pop this part down here and slide your tap in. This side goes up into the unit. These are not what I wanted to show specifically, but the fact that you can tighten these top plates to control how much torque before the center spins freely lets you adjust them so that they don't break taps. And that's really handy. So what does that have to do with anything? Well, I found this guy. When I saw this just perusing through eBay, I figured, oh, this is really interesting. This might really work. So I didn't know anything like this existed. It's an odd looking tool, right? Well, it is a Morse Taper 4 2 tapping, torsional tapping holder adapter right there. Let me tap things on the lathe, which I usually use the tailstock for, with the advantage of if the torque gets over a certain amount, it'll spin freely and not break the tap, plus it holds the tap dead center. Normally, what most of us have been doing over the years is we use a spring center in the back of the tap and a standard tap handle and go from there. This guy might be a big time saver. Because I have whole sets of these, I can fit most common tap sizes, both metric and standard. So very handy because the tapping arm is pretty fantastic, but a lot of times you're on the lathe and you want to tap a hole right down the center. I think this will be a good way to go. This was not terribly expensive. There's the part number if you want to search for it. MT4-GT12-110L. And these are GT12 tap holders, torque limited tap holders, something like that. All right, let's move on. Next up, I just love measuring tools. Even if I don't have any specific need to use them, I'm sort of in love with them. And so when I find a deal on some, even for things I don't need, I pick them up. These are two good examples of that because they're kind of crazy. These are chamfer depth gauges. And this is specifically for a 127 degree chamfer, which is a really odd size. I just thought it was really cool. I got these for very little money. So it wasn't that they were expensive, they're just really interesting. Set to 20 thousandths. That's 127 degree, and this guy is a different variation, as you can see right there. And this is for 120 degree chamfers. I got both of these for almost nothing. They come with a setting ring. Here's a chamfer guide for what a 120 degree chamfer looks like. And there's a setting ring including in here 0.260 depth. However, it looks like the gauge here is not working right at the moment. So we might have to take this apart and see if we can get it working. You can pull the end here. It looks like I need to get a pin gauge to get this end cap off on here and find out why the sliding portion is not working. I was considering making a special tool that would have a pin that would fit in here that would have this diameter, but with these soft jaw pliers, I was able to loosen the end. I'm kind of curious if I can figure out what's wrong with this guy. May not be able to. It cost me almost nothing, so I'm not out anything. There we go. Wow, okay, so it was a tapered wedge, and looks like whatever lube's inside's gotten really sticky. Whoa. Okay. Interesting. The ball bearing prevents it from coming out. Okay, I get it. Got these really large Q-tip. Harbor Freight sells these Q-tip sets that come in a bunch of different sizes. Really handy. I can remove the old lubricant out of here that's gotten all gummy and sticky, and hopefully that'll fix my problem. You can see right here, you can feel right here how sticky this is. So I'm sure that just gummed up the, this line here is the measurement line. And I'm sure it just froze this piece because this piece is free to move inside here. Now, can I get it back together? That's the question. It's going to be an interesting assembly. The 3 ball bearings here, they are really close fit. And these ball bearings prevent this from coming out. They keep it, there's a little lip back here that they sit in. Wow, okay, so this is a very interesting. Almost feels like you need to add a little grease to this to hold these in place, because they're not going to want to stay on their own. This is going to be really challenging, because this wedge against the ball bearings keeps this piece in place on the bottom. They must have some sort of jig for putting this together. It's kind of impressive. Or maybe they just use grease. I don't know. It wasn't particularly greasy when I disassembled it. Okay. And then get the wedge down the middle of this guy. Nope. Okay, so we got this guy fixed. It was just really grungy inside. So this resets the device. Then you plunge on the ground till you touch the ground face here. It tells you how deep you went to all the way. So let's see how close it is to the preset. Supposed to be 260, and look at that, right on the money, 260. There's a fine adjust inside. Anyways, nice tool. Probably never use it, but very cool anyways. I'm just happy to have it. Love beautifully made tools, and this one was inexpensive, so the fact that I spent some money on it's not a big deal. Next up, I have a tool of the highest quality and just funning with you. 1, 2, 3 blocks here, made in China. And you're probably wondering why I bothered with these. These are the solid 1, 2, 3 blocks without even a hole in the center. So they're 1, 2, 3, and they're essentially a hardened piece of steel with dimensions 1 by 2 by 3, hardened and ground. So looking at the price of these, which was 10 bucks each, $20, got me 2 pieces of stock that is 1 by 2 by 3 ground and hardened. So it comes with the Cosmoline on it, which you can take off with kerosene. This is isopropyl alcohol. It doesn't do quite as good a job as kerosene, but it does get the job done. Just got to do a little more work. By the way, you may have noticed I keep my isopropyl in this misting bottle. Works really well for distributing a very fine coat of isopropyl over a bunch of stuff. So, kind of curious how close these are to 1, 2, 3. Kind of in the way here, but so zero this off on a Starrett 1-inch gauge block. Okay. Sorry, camera's right in the way. Looks like 1/10 over to perfect. Maybe 2/10 over in that one part there. Let's see. Let's go back. Look at that. That is freaking right on the money. Holy cow. And look at that one. Okay. That's insane. So these are moderately precise gauge blocks for $10 a piece. That's insane. By the way, this is a tenths indicating indicator, so each small division is a tenth. That's a thousandth. As I said, the ground finish is not bad, but it's sort of rough. It's not a very super fine glass finish, but I'm kind of curious how hard they are. And the only way I can do that is put this on my hardness tester, which means I'm going to damage this finish. But we'll do it for science, right? All right, so we're going to pop one of these on the Rockwell hardness tester. Make sure it's preset. Oh, this is killing me. Let's make it close to center. We can take a precision flat stone to remove this after, but it's still killing me. Okay, so we got to get the little hand till this dot here. That's the preload, and then zero this guy out. Let her rip. I'm thinking it's not super hard just based on what I'm seeing here. Actually, the needle's not moving a lot. Maybe it's harder than I thought. Oh, I lied. It's Rockwell C62, so plenty hard. Holy moly. Left hardly any mark in the surface at all. So what we have is two Rockwell C62 123 blocks that at least the 1-inch dimension I measured here is accurate to within a tenth. A tenth. That is absolutely insane for $10 each. Now the reason I was looking to buy these was I was wondering if I could get some inexpensive stock that's pre-hardened to make parts out of. And I guess the answer is sort of. Rockwell 62 is very hard. So that might be a little bit problematic, but it's probably machinable with a bit of work. I'm not certain of that. I mean, carbide's harder. Boy, it would give your bit cutting tools a real workout. But $10 a piece, 123 blocks, very accurate, decently ground, decently finished. Rockwell 62 hardness. That's insane. One last thing. Check this out. The finish isn't super smooth. I can almost lift the block up with the finish on them. Who'd have thought, right? Can't quite lift it up. Still very impressive. This is a WERA, and this is a nicely made tool. You know what you're getting with these guys. This is not a torque driver. This is a ratcheting screwdriver. So there's lock in the middle, left, right, for tighten and untighten. Pretty nice. I bought Snap-on's version of this many years ago, and I use them every day. Matter of fact, here's one of the original Snap-on ones I've got. These things break. I went through 3 of these things when they first came out, and the Snap-on guy kept replacing them. Not particularly excited about those, but I think they've come a long way. The latest Snap-ons lasted me quite a few years, and this one seems to be reasonably made as well. It is WERA, so it's made in Germany. Nice quality tool. And in case you were wondering, I probably showed this a while ago. Speaking of torque sets, I did buy a WERA torque driver set to set my bits up, my cutting tools on both the lathe and the mill up. That's why I got this guy. Has all the bits and high quality, 3 different torque ranges depending on the handle you choose. This was a nice set. Picked it up off Amazon. Also WERA. Made in Czech Republic. Interesting. Where is this one made? Does it say? This one's made in Germany. Okay. So this WERA was made in Czech Republic. This one was made in Germany. And it comes with instructions that were hidden under the foam that I didn't even notice. So I just discovered that one right now. Next up, I have a tool made in India. and the box is falling apart. It did survive the shipment here, but just barely. They didn't have this in Morse Taper 2, or 4 rather, which my lathe tailstock is. Ravish International, manufacturer, trader, and exporter. This is an adjustable position live center. This guy is Morse Taper 3. Okay, so it's close. I couldn't find Morse Taper 4. I guess that was it. And my lathe is Morse Taper 4. I guess they figure anyone with a Morse Taper 4 lathe, which is, you know, outside, just outside the hobbyist realm as a common lathe product, was not who their target audience was. But I thought this would be handy. This is a Morse Taper 4 to Morse Taper 3 adapter, so it is Morse Taper 3. So this guy fits in the tailstock. It is a live ball bearing sender over here, and it lets you adjust an offset if you want to do a taper on a lathe that you don't have a taper attachment. Fairly smooth, not as much friction. Looks like you might want to, that might need to be adjusted, the shim in there, because it's not particularly tight, and it looks like it's got a lock on the other side. Or maybe that's what holds this guy in. I think that's what holds it in. So it's not super well made, but they did grind a bunch of sides of this, which is interesting that they went to that effort. But it doesn't look like they ground the dovetail. Inconsistent friction across the range. This is the brand. It's a really, I think all of them on eBay are made by the same company. Quite a bit of lash in the screw, as you can see there. You can see that play there. That's not great. That won't be helping you out. Probably need to loosen and tighten these guys a bunch more. They use brass shim in there in the dovetail, and they just machined that. All of these adjusters were completely loose, so it definitely needs some tightening. So normally you don't want to offset your tailstock very much. I found by tightening the gibs on this guy, you could get the shim tight enough against this that you'd lose almost all of that play that it had before. However, it won't go full range then, and I think it's got some serious issues. This end section here does not have a thrust bearing, which it really needs to press against this. This shaft is just threaded in the end here with a captive nut, and so if you're going in this direction and you go too hard, it'll untighten the nut, and this whole thing will just screw right off the end, and you won't be able to move the shaft at all, which is kind of cheesy. So I give this a thumbs down. I think it's got a great concept, but I don't think it's there yet. You might be able to make this work for a very small range of offset, which a lot of tapers are, so it might be okay that way, but bottom line is, not well made. Strangely spent some effort on parts that don't matter and no effort on parts that do. Gotta go figure. All right. Next up, an acquisition mostly because I was curious about it because it's so ridiculous, is the world's smallest precision grinding vise. If it is actually indeed precision. If nothing else, it's a really cute little vise. Interesting on the design. So this threads through here, and it's actually very close to sticking proud of the bottom, which is a problem. Normally these things are drilled all the way through, so for the pin, some of them you can manually pin all the way through with a fixed pin if you don't want it to change, and the adjustable runs inside. This one they just drilled from one side, so you can't stick a pin all the way through. It does have these interesting spots where you can thread this guy down on a bunch of different spots, on the fixed jaw up here, down below, on the base in 2 spots on each side, and on this bottom in 2 spots. It's a cool little vise. It wasn't terribly expensive either. Here's finger size. It's a 1-inch vise. That part's nicely ground. It's funny, they only ground this top part here as a super shiny finish. And I like the relieved edges on the fixed and moving jaws where you can hold something really small up there. This could be really handy to hold inside another vise to hold a really small part. If you're wondering, the manufacturer is AccuSize, which is Canada, made in China or Taiwan, Canadian company, I believe, AccuSize. There's the part number if you want to see. Next up is another adapter for the adjustable torque tapping inserts. And this guy is from a fixed size keyed shank to the insert holder. And I purchased this one because I was thinking about making something for the milling machine as well. It could be really handy. It'll hold the tap vertical, at the same time prevent from totally destroying the tap with too much torque, hopefully, although with the inexpensive ones, setting the torque adjust is a little challenging. This is also a GT12, 14 millimeter shank GT12 is what this guy is set for. Next up, I got this guy at Harbor Freight. I thought it was really an interesting tool that was very inexpensive, and it lets you probe neutral, hot, and low. I guess neutral, hot, that's actually interesting. I'm not quite sure which one's which. Line splitter, neutral E, I guess that's low, and that must be ground. I don't know, that's pretty weird. I don't understand the designations on that, but the prime reason for this is it's got one coil in here, one wire for the hot and the neutral, so you can take your clamp meter and measure current, or times 10 if it's really low current. They obviously have 10 coils looping around in here, so that your amp meter can read 10, it'll show 10 times the current just in case it's a really low current. Pretty neat little tool. I think we should pop this open just to see how it's made. This is a Harbor Freight Ames tool, and I'm really curious about this too, because neutral and low or line, I don't know, I'm not quite sure. Oh, E for earth ground, maybe that's what it is. It's neutral, hot for line, and E for, I don't know, that's weird. All right, so as I was saying, you've got a single wrap. So let's see, small one is hot. So hot is coming straight through here with a single wrap. That's the L. Ground for this guy right here. Yep. And this is neutral, which I thought with European standards, I thought blue was hot. I'm not totally familiar, but I thought the colored was hot in European standards. You wouldn't want to measure current on this side. They actually didn't say that you shouldn't measure on this side, but you shouldn't measure on this side because you'd get the neutral and the ground also coming through there. This side would be the pure leg. So you've got to measure on the side with times 1 and times 10. And again, 1 wrap here, 10 wraps there. This will make your current appear 10 times larger than it actually is. The plastic is really soft plastic, very chintzy, but the unit's stable enough if you don't take it apart, so don't take it apart. All right, so it's rated at 15 amps, although the gauge of wire in there looks like you could probably get away with more, but I wouldn't do it only because, you know, the circuit boards may not be able to handle it, and plus these cheesy connections. But all in all, interesting tool if you have a clamp meter. If you want to measure consumer stuff that you're plugging in, just make sure you grab across the where it says times 1 or times 10, not on this side. Next up, I'm not quite sure it's in this box. I don't think it belongs there, but I found this fairly inexpensive. Looks like it was hand scraped, or at least scraped bottom. Precision two-way level. Made in Switzerland by Weiler. Yeah, I don't think it belongs in this box, but pretty cool. Lets you do 2 directions simultaneously, 20 arc seconds, or 1/1000 over 10 inch for the tubes. Pretty cool. I've got a thing for these things. And you can permanently mount this. That's also interesting. Second to last item is another part from AccuSize. Here's the part number if you want to see. Also AccuSize tools. This is a milling machine indicator holder. Fits in the quill. I think I'd like to make a clamp that fits on the outside of the quill. Be easier to go off and on with this. You actually need, it was shipped this way, but you need to flip this over 180, obviously. All right, so this was shipped upside down, but it goes like this. Fits in the quill, and then you've got fine adjust here, and you can lock it off after you're done. It fits a bunch of different size indicators. Look at that. It fits that diameter shaft, whatever that is, the small one, and dovetail. So I thought I'd give this a try. It wasn't super expensive, but it wasn't cheap either. I think this was like 50-something dollars. So I will give this a shot with an indicator on the quill of the mill. And next up is a total piece of crap that might work, but this is pretty poorly made. I got this from McMaster-Carr. It cost $120, $150, something like that. SDA manufacturing, shame on you guys. This thing is really poorly made. Plastic cap here. It's all aluminum. You think that if you want to put this in a collet, you would make it out of better material than just aluminum, because that's going to wear. So this is a laser finder, and at some point you just rotate this and it's supposed to make contact. It looks like it is not. So it looks like the batteries have died on, oh no, there they are. Yeah, the batteries have died. I can see it, but it's not visible. So it puts a tiny dot. They collimated it pretty well, but as you'll see later when I demo this thing in another video with my center finding techniques, this is just not well made at all. Yeah, I don't want to look in the laser directly, but off at an angle, I can see there's a little red glow there, so batteries are just toast. All it's done is sit in the box here. I put new batteries in it when I got it. The fit and finish is poor. It's made out of aluminum instead of steel with a plastic, cheesy plastic cut end on the end piece on it. They did a good job of collimating the light because it doesn't spread very much. So that's good, but not impressed at all. Absolutely not worth the money. This was like a month and a half worth of YouTube revenue that I just reinvested. Total waste. Don't recommend it at all. So here you can see this thing. You can just barely see the light. It's a fairly small dot, and it doesn't get a whole lot larger the farther away you go, a little bit. Closer you are, the tighter it is. There's a fair amount of light here, so the fact you can see it at all is reasonable. But the switch is totally hokey, this plastic thing. It basically just lifts two contacts apart, but it's totally hokey feeling and looking. Totally cheesy. Shame on them. And on that note, thanks for watching. Hope to see you next time.